Hello folks. Okay, thank you again for joining me. So this is my second video on this series I called AI Security Engineering and Architecture. This second video actually should be like the first real thing. The first video was an introduction. Now, out of the 80 domains of AI Security Engineering and Architecture I introduced in my first video, I want to take on the first domain. And this first domain, I call it AI Security Engineering, the very foundation. Now, on this video, I am going to build local lab. The next thing I will do is show how we can understand context window in LLMs. I will move forward to hallucination, how hallucination can be a risk, a security risk. Then from there, I will build what I call embedding, because as a security engineer, you can only secure what you know or what you can build around. So I am going to show us the concept of embedding, then how to do what we call similarity search. Then after all these things is done within the lab environment, then I will try to simulate some scenarios to break of this model that we'll be using. Then I will do other things to defend it. Then maybe in other videos in future, we can see how we can deploy this at scale. So thank you once again as we go into the lab, because I said it's going to be lab. So everything I'm going to show, I'm trying to, explain it from practical perspective. And that is what we do. So, yes. So the first thing I want to do to prepare the lab environment is to install Docker. And for those of us that maybe we need some more information, we can just do some Googling and we will get around it. But the first thing I did here was to just prepare, put everything in a script. And if you look at here, you will see, on the left hand side of my screen, you will see the script. And those scripts will be made available on my GitHub account. You can take a leaf from there. So what I did, but before you do this, make sure you have your Python installed. Make sure you have your VMV environment. That is your, virtual environment setup and stuff like that. So the first thing I want to do here is to install Docker desktop, most especially. So now, when I do this and run my script, so what this script does is to install Docker. That is just some other things that needed to be installed. And so you can just do your version, and you see that Docker is installed. We have version 229.5.3. So it's a new installation. So when you have your environment, your Docker environment, taken care of, yes. So after the Docker desktop or Docker environment is set up, the next thing is the next thing to be installed or set up the LLM. So this is open source. Anyone can have access to it for you to build up your lab and stuff like that. So likewise, like I did with the Docker, I have also put it in a script here. So if you look at the script very well, the only thing it does is to pull the information, pull LLM from the repository and set it up. So we quickly do that. We say, okay, so installed. Also, when I run this, so it will take some time, but normally for me, it's a new installation for me. So for you, it might take some time. So you take note of that. But for me, it's a kind of something I've just done. So it will just run through. And if it's taking much of the time, I can pause the video and get back to it. So Olama is installation is complete, and for you to be sure of that, you can just do normal space. Let's do the normal version, and you see that Olama 3.0.3.0.8 is installed in this environment. So if you look at what we have done so far, is that we are preparing our, let me call it, development environment. So now, but the Olama mode, now that is what I want to deal with. That is what I want to pull and download into that engine. So my script is here on the left hand side, and I will run my script for you to see how that works. So I have an old installation there for that, so it might take some time, but not so much time like a fresh installation. So all things good, we should be able to use Olama list as a command to check the the download and the setting up of the model itself. So we'll verify that by using a Olama list. So if this is taking maybe too long, I will pause the video and I will come back to it. So Olama model is installed. So if you look at a warning on my screen, it says that no NVIDIA AMD GPU is detected. Yeah, so I'm using a 60 GB laptop to do this, and my VM machine is like maybe running like 20. The NVIDIA GPU is not there, but the CPU is there, so at least it's running that. It's serving that purpose for me. So, oh, we have an error there. One sec. Okay, so what happened with that error is that Olama is already running in my environment. So if I just say Olama should list, Llama list, you can see Llama 3 and test out and gain knowledge and have the understanding of how things work. So yeah, so with that, we will continue from there. Okay, so the next thing I want to do is to start the Llama model itself. Put it in a chat mode. I can ask to say what is the capital city of Canada, and just for us to test that the prompt the model is working. And one thing I want to say is that this is a local server, and it doesn't have the resources as much as it should. So it takes some time for the prompt to bring to give output. So it's just reading out the output, one letter by letter. So it's kind of slow. You can compare it to the infrastructure that is being used at scale in our enterprise environment. So just bear with me. It's just let me say it's just so. If you look at this, the output, final output, it says if you are looking for the federal capital of Canada, it's Ottawa, which is located in the province of Ontario. So this is what I was saying, because my context did not provide enough information as to the kind of specific output I'm looking for. Then you can see that context affected the output of this particular prompt. And that is one of the things I'll be looking into, any moment from now, is the standing of embedding. So yes, so it's very important that we see this, and we'll come back to it later. Okay. So the next step in this lab is to do tokenization. Now, if you look at my test here, you will see these words. These are the words or tests. Let me say these are the tests I want to tokenize. So now when I run my script here, you will see that artificial has a token number of this, or let me say token ID of this. Security has a token ID of this. Now you can see there is an extra token that it seems like we don't know where it came from. If you look at supercalifragile, I don't know what is here, but this is something that doesn't look like a normal English text. And when you have things like that, you can see it generate a lot of token ID, a lot more than what we can imagine here. So that is to give you an idea of why writing context in such a way that a token will be understood. It's very important as a security engineer and architect. So if you look at it, we have 11 tokens here. I know it's taking shape now, but by the time we get to some other part of this, then we begin to see how they come together and they make sense. So like I said, so let's move to a lab to demonstrate context. Now, yes, to demonstrate context. Now I have here a prompt that says remember this number. It's end with 281. So let me run this prompt. I'm just telling the prompt that, okay, remember this number, and it is telling me that I've remembered the number. So I told you it's going to take some time because it's not a high-end utility server. So now it's going to be difficult to demonstrate this here, but I'm going to explain what I want. Let me say 50-word essay, because I want to have iteration of this prompt, like have conversation with this prompt multiple times. So when I ask you to write a 50-word essay, the intention here, what I want to achieve here, is that I want to fill up the context window for this prompt, so that by the time I ask it again, that do you still remember that number? I want it to kind of forget, because the context is like a memory window for a prompt to be able to put things in that session, to be able to hold things in that session. So if you use your context window more than enough, you will realize that the model will not be able to hold some information in memory anymore, and it will forget some stuff. So that is what I want to achieve here. So now if I say, what number did I ask you to remember? So it's replying, giving me an output that you asked me to remember number 9 blah 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 281. And if you look at that number, you see that it's the same number. Now, what I'm supposed to demonstrate to you is that it will not remember that number. How do we achieve that? Is by filling up. If I ask it now to write maybe 15,000 worth of essay, that might fill up that, but I don't have that resources to do that on this server. But that is the concept, that bad actors, if they have access to your prompt, they can fill up the context and make your model misbehave or hijacked or do something that they are not and is not supposed to do in the first place. So that is the concept I'm trying to show here. But because my server is kind of very slow, I might not be able to fill it up the way it should. But if you have a server that can do that, try it out. The expected or the expectation is that it should forget that number. Now, the next thing I want to demonstrate is hallucination. Now, hallucination is okay. Let me say it's a bit technical. I've noticed that when you want to trick a model to hallucinate, you tell it some what I call plausible that look like they could be real, but they are not actually true. So for instance, I say, tell me about the programming language hypertrust. Now let's wait. It might take some time for it to gather its thought and reason and stuff like that. But if it's taking more time, okay, we have it. You see, he said, I'm not aware of programming language called hypertrust. It is possible that it's hypothetical or experimental language, or it could be mistake or misremembering. If you are looking for information on programming languages, I'll be happy to help with something. So if you look at the output we are getting, it's not entirely wrong and it's not entirely right. But the concept I'm trying to, demonstrate it, that is like trying to say, okay, tell me, I'm not aware of this programming language, instead of like being divinative. No, it's kind of going around to say, okay, it's possible that it's hypothetical or experimental or what have you. So now, depending on how sophisticated the plausibility of your statement could be, this could derail the original intention or the workings internal LLM itself. So it's worth noting, yes, these are the ways through which hallucination occurs or be introduced to your workflow. So, like I said, so if you look at the output we got, it's not, we cannot say this is hallucination, no. Or this is what is called behaving conservatively. It doesn't want to like declare, okay, this is wrong or this, no. So, but if our statement or my statement is plausible enough, hallucination will kick in. So one of the key things you have to remember in hallucination is ability to craft prompt that is plausible enough for that particular language model to hallucinate. But either is still a good thing to note. So I want to demonstrate, but embedding is the context around it and some other information and encode it into numbers. That shows that the meaning that your output carries is encoded in numbers. So if you look at what I did here, I ran my script here and it shows 384. That shows that this particular test that I embedded here within this model, which is artificial intelligence security, came out, the meaning came back as 384 embedding. Now, I don't want to go into some technicalities, but the major thing I want us to understand here is the concept of embedding, if you can look at it here. So I'm using a different kind of mini model here to do the embedding. But the concept I'm trying to, the message I'm trying to pass is the fact that embedding captures the meaning, the context, and some other information that of your test, and that helps in producing the output by the model. Now I have a script here to demonstrate this concept better. If you look at my transformers here that I imported here, you will see I have some docs here. This is more or less like my vector, like information within my vector database. So I say, okay, how to secure. Now this is the document I have, like information made available within my database, within my data source, like knowledge base. Now my query is, how do I secure AI system? It is expected that the outcome of, or the output of this prompt or query should be coming from among these available options within my document. Now, when I run my script here, let's see what happens. Okay, so you will see that I have And the question I ask is, how do I secure AI systems? Among the three options we have now, you can see that machine learning security comes first in terms of the embeddings, the way the embedding is captured. That is to tell me that is to tell the system that the most likely answer to that question is machine learning security. And if you look at it from a rational point of view, you will see that there is no way it could have been how to secure Kubernetes or how to cook pasta recipe or whatever. No. The most compelling and closest to it is machine learning security. And this is how embeddings work, and output and meaning are captured. So I want to move forward and explain the concept of prompt manipulation. I have some series of information here that I just want us to go through. It's just something basic, just for us to be able to see the. So now I have something here. I say you're a cybersecurity expert, and then another one I want to say it's taking some time. All right, too much. If it's taking too long, we pause the video and I will come back to it. But if it's not taking too long, then I can move to the next prompt. So under the prompt manipulation, which is safe to say prompt injection, what I'm demonstrating here is this. I just want to show you some of the. If you look at here, I ask the model to be a cybersecurity expert, and it's kind of take me through some of the capability it can deliver in that capacity. And again, I ask it to ignore previous instructions. It doesn't really do that right away. It just say no problem, let's start afresh. Still refer to cybersecurity. And if you look at here, you are now a pirate. You can see the way it was able to loop the capability of a cybersecurity with being a pirate. If you look at the conversation here. So now I move forward and I say, hey, in two-liner, can you explain networking? And it was able to do that, connecting the idea of networking with pirates, functionality and jungle and stuff like that. So it does that. Now, the next thing I want to do is to say, okay, what about you ignoring system instruction? Let's try to do that and ask it to ignore system instructions, and let's see what it's going to produce. So the idea here is that I'm trying to manipulate the prompt to see if the model will be able to give information that is not supposed to give, or is supposed to behave in a certain way. It's more or less like a recon to know how will it behave under certain manipulations and queries and stuff like that. So if you look at this, it says networking is interconnecting, even though I ask it to ignore. Okay, I think the spelling is wrong there. Let me stop that and kind of bring this to. Okay. So let's see what it gets. So I might have to pause it so to my point, if you look at the sequence of the result, you will see that even when I ask it to ignore, certain instructions, previous instructions, it doesn't automatically erase it. These are validations that, okay, these are the capability and this is how the model works. So even though there is an attempt to derail, to manipulate, or to inject some prompt into the model to cause it to disclose some information that it shouldn't. You can see that it's kind of consistent, trying to pull those information together, because at the end of the day, the system process has a higher priority, while the user process has a higher priority than what I call the content. So there are things that, so for instance, let me give that a try. So because sometimes the idea is for us to test and see if these manipulative queries and prompt will cause the model to disclose sensitive information. But if you look at it, it's just saying fresh start. I'm just an AI. My primary function is to understand and respond to natural language input. I can answer questions, provide information, and even generate text based on a given prompt. You can see. So even when I say it should forget previous context, it's trying to role play and do its role playing and stuff like that. So these are very, very important for security engineers and architects to know the capabilities, to know the risk factors, the attack surface, the threat surface, and stuff like that, so that it will help us to build to design and be able to test for secure system. Be able to test for secure system. So yeah, okay. So the next item on my list is to talk about sanitizing prompt. It's a way of defending our prompt to make sure that it's not being used or misused. And if you look at the block session, these are the phrases that my script is blocking within this pipeline. For instance, ignore instructions, forget instructions, override systems. Everything here should be blocked. And let me demonstrate that to you, that when I run this script, you can see the prompt is here, and I say override system. When I use this and I say override system and I say enter, you can see prompt blocked. But if I say go to market, you can see prompt allowed. So this is one of the ways through which we can defend our system within this environment. And with this, I think I've come to the end of this particular, it's a long one, but I really want to make sure that everything fall under, like, we're able to do something I can call basics of how LLMs works, how AI applications work, how security, systems and tooling principles within that space can be applied to achieve basic security controls and solutions. And thank you once again for joining me on this.